Hello, friends and students, welcome back once again. So I have built a new project, that is, I have built a new project in a series, that is, we are continuing with the series, that is project series. So this is a project name is Smart Motion Detection. You can tilt, shake and free fall Arduino ADXL345 Accelerometer with 16 cross 2 LCD. It's a normal LCD. So I'll just tell you what is it exactly. So there is a sensor, that is ADXL345 digital accelerometer sensor, which will sense 3 axes, X, Y, Z. So these 3 axes, whenever there is a tilt anywhere, so I have designed in such a way that you will get an alarm. And the whole thing, how much tilt is there, it will be displayed on the screen. So I will just go to the next slide and I will explain you what is it exactly. Okay, right, okay. What are the key features of this project? Threshold detection, that is X and Y. There's a threshold I've set to 10, we call it as, from gravitational force. So that amount, that number is 10. Up to that, if it crosses that, then you will get buzzer and the light. Visual and audible alert. Of course, audible alert means there is a buzzer also, but I have not used buzzer in this project. I can directly replace the LED with the buzzer. Don't you worry about it. Okay, you can also do it. LED flashes when the threshold is exceeded. Buzzer sounds at 1 kilohertz tone. Okay, we can set the tone also in this. LCD display which acts triggered the alert, X, Y, or Z. Right? Gravity compensation. Right? X-axis automatically subtract 9.8 from that, and earth gravity will be calculated. So all this thing will be there in the code. Okay. Now we'll go to the next slide. What are the components used? The main components used are Arduino, ADXL345 accelerometer, that is I2C module. Okay. Okay. 16:2 cross LCD non I2C parallel interface, 10 kilo ohm potentiometer for, of course, for the LCD, breadboard, jumper wire, LED, and buzzers. These are the only component. It is very, very cheap. Okay. And please remember, ADXL345, usually we have different accelerometers in the market, but this accelerometer is a little different. So I thought, why not to make a project based on this? So these are the components required. These are the connection. Very simple connection. That is 16 cross 2 LCD non I2C. There are, what are the connection? How we have given, that is RS, RWE, D4 to D7. All these things, that is character generator, are connected to the Arduino board. That is D7, D6, D5, D4, D3, D2. These are the Arduino pins. All right. ADXL345, only 2 connection, SD and SCL. It is given to A4 and A5. Please note that it is LCD, even ADXL345 works on I2C. Please remember that is this thing, because you get in the market different type of accelerometers. That is non I2C also. Okay, so next is LED and buzzer that we have connected through a resistance of 220 ohms to pin number 9 and number 8. Okay, so simple connections, not much this thing. So that's why I'm not giving you the complete circuit diagram. Okay, where is the application? What is the application where you use it? Motion detection, tilt, shake, and free fall. Okay, number one. Orientation sensing for robotic drones. Okay, orientation for robotics and drone, it is used. Vibration monitoring, wherever there is, you want to monitor the vibration. Step counting, gaming consoles, gaming drone related project. You want to keep it steady and all. Plane and submarine radars systems, earthquake intensity measurement and calculations. Right? Intensity of measurement and calculation. So these are the projects where you can apply this. Okay, how to use this? Upload the codes to the Arduino. Tilt, shake the ADXL345, exceeds the threshold. Observe what happens on the LCD, shows the which axis triggered, then alert, LED flashes, and buzzer beeps. Return to normal when it is limited. Okay, so this, all these things we will check on our live video.
All right, so you can see in this project 3 values X, Y, and Z, which is constantly moving, right? So what is the name of the project? I will just tell you first. Before that, I will just show you, I'm making the movement, you can see here, when I make a movement, the values changes. Why the value changes? There is an sensor, that is accelerometer sensor, that is ADXL345 sensor. Okay, so this thing which have two LEDs also, that is I have made a threshold up to threshold values. When it bends a lot, at that time it will change the values. All right, it will change the values, that is it will give you an indication. So that is the project exactly. Right, you can see now a threshold based vibration movement will be there. So I will just try to move it. Why? Because the accelerometer, I'm just trying to move it and wanted to show it to you. What happens to the oscillator? You can see the LED came up. When the value goes to that threshold, the value has changed over here, and the light also came up. Okay, this is live slow motion detection, smart movement detection, or motion detection we can call it as. Okay, so I'm just showing it from this thing on a different angle, how it is working and all. This is the main accelerometer, and this is the main accelerometer. So I will just tilt it and I will just try to show it to you how, and we will just move it faster, right? So you can see I'm doing the movement, so the lights are coming. Okay, so suppose the vehicle is shaky or something is rough, then the movement will be very high unless it becomes stable. Okay, so you have to see the movement. Once again I will just try to show it to you. I'm just moving it around. Okay, 1 2 3 4. Okay, this is so I can put both the things, so it comes to normal, fast, right? Okay, so this is the live. Okay, I'm just moving the board, how the values are changing, X, Y and Z, 3 values, because this sensor or this ADXL accelerometer sensor will have 3 values. But I made it onto some threshold. I will show it to you, and how it happens. See, you can see the lights have come up, the values have crossed the limit, and it has again come to the position, like it will come to the position. All right, so I will just tell you. All right, now I will tell you. You can see here, I will just press it once again. I will just show you once again. Okay, this is the second, and smart motion. Okay, the motion, now you can see it is axis 0.2, and y is 0.5, and z is 9.5. so suppose I'm just turning around, you just have a look around, and I will just keep an eye on the LED. I'm just turning the accelerometer. So if it crosses that limit, threshold limit, what happens? You will just see what happens to the threshold limit. If now you can see the lights have come and gone, right? So that was the limit. Okay, that was the limit. So that threshold limit, if it crosses, you can see, you can directly see the threshold limits that I will show you on the codes. So I will tell you, I will show you what are the things and all, how it is coming. You just watch it, x axis, y axis and z axis. So any of the axis, if it crosses the threshold level, you will get a light indication. Okay, light indication. So if it is moving very fast, the light indication will be continuously will be there. Now I will just tell you about the circuit diagram. So I will first tell you about what are the parts and how it has been connected. Okay, right. Okay, now you can see, first the only main thing is Arduino board. Okay, Nano, whatever you want, you can use it. I have used 16x2 LCD, and I have used the main part, that is accelerometer. What accelerometer? It is ADXL345. that is your 3-axis accelerometer. We call it as X, Y, Z. Okay, it is a not very common. We use nowadays, we have different accelerometers in the market, but even then this was with me, so I just wanted to show it to you. All right, this accelerometer has 4 connections will be coming out, that is SCL and SDA, that will be going to the analog pins of your Arduino, and supply will be 3.3 volts. Of course, this will work on 5 volts. How the connections? 1, 2, 16 pins are there. So one starts from here. Please remember, the students will be having a little problem understanding from where we have to take the one number. So first is the place which is very little place, and here you have a lot of space here this side. So from here you have to take it. First is ground, that is number 1 is ground, number 2 is the supply, that is 5 volt, third is the contrast, that is V0. RS goes to your, that is character generator, it will go to the pin number 7, okay, and E will go to pin number 6, and D4 in between 4 points are dummy. D4 to D7 will go to pin number 5 to pin number 2 of the Arduino. These are the pins, okay, beginning. Okay, now here I have used 2 LEDs. Please remember, I can use one this thing also. What I can use a buzzer also. But
the students, we are into the code part, okay, the code part. So I will explain you about the codes and all. So what are the libraries we need? So we need a library that is that wire.h, that is compulsory Adafruit sensor library. Universal library will be there, ADXL345, and liquid crystal, of course. Okay, so 675432 as accordingly we have connected. Adafruit unified libraries we have discussed before. Accelerometer object and buzzer pin, we have kept it on pin number 9. You can see it here, and the LED pin we have kept it on 8. But we have used, instead of buzzer, I have used only light, only one more light. That is, I have used, instead of buzzer, I have used another LED only. Okay, so now you can see here trigger pin threshold value alert. I have given it up to 10, right? This is the important for threshold value, what I was talking to you. Okay, these are the 10. In my serial begins. Why? Because we can see, you can see here the motion alert, because I have shown you when the motion with the light comes in, immediately it will show you on your serial monitor that the motion has been activated or motion has been. So first time initializing, first time on the display it will be initializing, and then if ADXL is not found, then no ADXL and other things, and okay, ADXL is there in range, then you will get the output smart motion that finally will be written on it, and you will get X, Y, Z values. Okay, these are the X, Y, Z, float X, Y, Z. These are the values for that. Okay, X is equal to this much, that values you will get it finally, and it will be showing on the screen like X value, Y value, and like this it will be shown. As buzzer pin, I just told you that this is the alert system. Alert system in your high motion alert, it's already shown. When both the lights, that is buzzer or lights, are coming, at that time you will get alert on your serial monitor. Okay, as well as how you will see physically, you will see when the light comes on. Okay, let's say that it is in the car, then it will be, car will be shaking and you will get light. That means you will become to know that we are into danger, or my car is tilted, or there is a lot of vibration, there is something wrong with my engine. It can be plane, it can be a car, or it can be submarine also. So wherever you have an idea, you can use this application. Very simple. I will share this code with you, and you can successfully, you can implement, and you can do your project, or you can think something new which is good or new type of project for you.